Hey everybody, Dave Lindbergh in Hong Kong with another episode of THD Podcast. Of course, we have to give shout out to our sponsor, Alti, formerly Alma, but now the Audio Loudspeaker Technology International. Great networking organization. Used to have trade shows, maybe not this year, but they'll be coming back with those to help with everything. So we encourage people to join Alti and get involved. Today on the episode, we have DSP Concepts joining us, and it's a technology that seems to be like, what do we call it? A compiler for all your coding and algorithm blocks. If you're trying to build an audio system, do you have to code for each chip, or can you use I use the word compiler, but we're going to learn more details to see if I've got that accurately. So without any delay, let's switch over to say hello to everybody. So Simon Weston joining us from Sendai, Japan. How are you doing today, Simon?
Really calm and peaceful today. There's actually a pitter-patter of rain.
Okay. All right. So yeah, joining us from the Bay Area is Mr. Paul Beckmann. He's one of the founders of DSP Concepts. How are you doing today, Paul?
Good. Yeah, thanks for having me on, and looking forward to speaking with you and telling you all about DSP Concepts and our AudioWeaver technology.
All right. So, yeah, I've done a little bit of homework, and I saw the AudioWeaver literally is like the concept of weaving DSP between different devices in an audio system. And I got a quote from you that I wanted to start this off with. So, in one interview, you said going from coding to AudioWeaver was like going from a typewriter to a word processor. So maybe that's a good place to start in tell us how you came up with this idea for the AudioWeaver with DSP Concepts. Right.
Yeah. So my background is I'm kind of audio DSP engineer. So went to school, went to grad school, studied signal processing, learned all the math and stuff. And my first job, I worked at Bose, and was there in the early 90s. And I was in a group doing research, and we were developing new 3D audio algorithms. So we were doing all this cool HRTF, spatialization, head trackers, all that stuff. And I remember late one night, I'm sitting in the lab, I'm writing assembly code for a TI processor. I'm like, I didn't go to school for this. Why am I spending like 98% of my time doing implementation issues like assembly code? And I felt like I was only doing 2% of the time doing actual audio algorithms. And so born out of that frustration was my desire to streamline that process and, make my work more interesting and allow me to work at a higher level. So at Bose, I started developing rapid prototyping tools. So we could do this kind of R&D work. Mm-hmm. And so we used it for 3D audio and so forth. And the tools were actually efficient enough to be used in product development. So the first product we did was a Dolby home theater system, so 5.1 channel system on a Shark processor. Mm-hmm. And then from there, it spread to Pro Audio Group, rest of consumer, automotive group. And those tools are still used to this day at Bose, the stuff that I started on.
And I guess you mentioned a Shark processor. That's a pretty heavy horsepower device. And now there's been more power in lower cost processors. Has it become more prevalent across all product applications?
Yeah. And I'll show you kind of later on the list of processors we support. Mm-hmm. But the bulk of our business nowadays is on ARM processors.
Okay.
And, that's driven by a couple of things. One is ARM processors have gotten fast enough over the years to do real-time audio. Second thing is all the interesting audio products have connectivity. So the moment you have a connectivity, you need an ARM processor. And so those two things together make ARM a real nice platform for audio. Yeah, so DSP Concepts, our vision is to create the audio of things. Just like everybody knows about the Internet of Things, that's where we're putting internet technology, connectivity into different devices. We want to be the audio supplier for all the different device manufacturers. So we say, we're creating the audio of things. And the way we're going to do that is by creating tools for product developers. Okay, we're going to create best-in-class tools for audio product developers. World-class algorithms, so we have some of our own. We provide systems expertise, and then we're also going to create an industry-wide ecosystem. So we're working together with chip partners, IP partners, design partners, and so forth. And DSP Concept was founded a long time ago, so 2003. And the early years were doing consulting. And we started working on AudioWeaver in 2006. And we used AudioWeaver as an internal consulting tool for our customer projects. Okay. And with AudioWeaver, we could pretty much whip out audio products that way. And so what was also nice, it gave us time to improve the technology. So we've been iterating on the technology. And audio is tricky to do because you're balancing efficiency of implementation with flexibility. Okay, so we started on small embedded processors. So we were always MIPS and memory tight. Okay, and then over time started supporting more more processors and so forth. And then in 2015, we kind of took the leap. We said, hey, let's fully productize AudioWeaver. We took kind of friends and family round, did some investment. 2017, we did our Series A round, and 2020 did B round. So we've been growing. We're up to 100 people now, so 100 full-time people. And so we're supporting lots of customers with the technology.
Okay, and can people select their algorithm? Like if somebody wanted to use a Waves signal like algorithm, could they that can be a plugin for your system, or how does that work?
Yep. So Waves is one of the partners we're working with. Okay, so they're integrating their technology, and it's going to be as easy as dragging Waves max bass out and hooking up in your signal chain.
Okay, cool. All right.
So lots of good investors. You'll see a bunch of automotive names.
Yep.
The reason is your car is your most complicated audio system. You've got a home theater system. You've got a conference room voice system, soon voice assistants, even fake engine sound. So they've been kind of struggling under the complexity.
Right. Okay. And quite distributed around the world. Looks like some key automotive centers of the world: Yokohama, Stuttgart, Detroit. Pretty automotive centric. So cool.
Yeah. So we've kind of been leading there with automotive stuff.
Okay.
Now, what I like to tell people is every audio product is unique. This is kind of the challenge for audio product development. Okay. If you're doing a touchscreen, it would be easier to sell the same touchscreen to a lot of different products. But with audio, you have different form factors. You have different use cases. You have different, performance levels and so forth. And so each audio product is unique. And you use different processors. Maybe you want to hook up to a different voice assistant. And so the challenge is, how do you mass customize technology? And that's kind of the field that we're in. The way I like to describe AudioWeaver, I like to say it's like the TensorFlow for audio. So audio as an engineering discipline is lagging behind all the other fields. So if you're doing a website, are you going to take Notepad and write HTML? Or are you going to use one of these frameworks for doing the website? Yeah. Of course you're going to do the framework. It's much easier. Graphics, people use Qt. They use Vulkan, lots of good graphics frameworks there. Machine learning, I talked about that in the beginning. If you're somebody who's doing machine learning, you're using TensorFlow or PyTorch or something like that to get your job done.
Right.
If somebody came to me and they said, hey, Paul, I want to do machine learning for you, but I'm going to write everything from scratch. So once I stopped laughing, I would say no way. There's no way you could be competitive with anybody. Yeah. And what's funny is when you look at audio, there's a big question mark there. There's something about audio, the way the audio field has developed, that everybody starts from scratch. Okay. Mm-hmm. I don't care if you're a big company, Harman, Bose, Google, Apple, they all start from scratch and they engineer their own thing. Mm-hmm. Okay. And we're kind of saying, look, there's gotta be a better way to do this. And so this question mark is basically where AudioWeaver fits in. Right. Is to say, look, don't start at zero. Okay. Start with AudioWeaver, and there's enough flexibility and richness in AudioWeaver that you can engineer whatever you want. Okay. That's the fundamental idea.
Okay. And again, back to what I said earlier, this is probably a lot enabled with the processing power that's available. I know that when I started in audio, like programming for real-time in RF applications, having a compiler could bog down the RTOS layer and these kind of things. So now with processing power, it's not an issue anymore. Is that, I guess, consistent statement?
So AudioWeaver consists of several different components. There's the designer tools that runs on the PC. Mm-hmm. And there's two versions. There's a standard version. It's kind of Windows application. Yep. Most customers use that. And then there's a Pro edition for kind of the MATLAB user. And that gives you additional scripting, testing, automation capabilities. Next part we have are these runtime cores. So these are optimized libraries for specific processors. Okay. So we'll have an M4 library, a Cortex-A library, a Shark library, a Hi-Fi DSP library. Mm-hmm. Third component is custom module SDK. So if you're an advanced user and you want to create your own block, you can basically use the custom module SDK. And often that's used for wrapping third-party IP. So if there's an existing Waves library, or we even had announcements with Bose, a Bose library, you can basically wrap it with that custom module SDK.
Oh, so they can, IP developers, or protecting yourself, having something unique rather than the same kind of blocks from every other company.
Right. Yeah. Okay. So those are the options. There's enough richness in the set of blocks we have that you can get most of your jobs done with AudioWeaver. It's kind of like TensorFlow. If you're doing machine learning, I've got convolution operations, I have nonlinearities. Most people use the existing TensorFlow blocks, and then you can engineer it with that. And the advantage is, if you use the existing blocks, then you have full optimized implementation across the processor families.
So just to paraphrase TensorFlow for people that might not know, that's basically you have an input and an output, and then what's in between is kind of like, I believe it's somewhat like linear algebra, figuring out what those formula is in between. And so basically what you're saying is AudioWeaver presents you the formula in between your input and the output. Right.
That's right. And AudioWeaver, we have, about 400 blocks. So there's a lot of low-level blocks, delays, mixers, compressor, limiters, more advanced stuff, beamformers, echo cancelers. And so the magic happens in how you connect the blocks together.
Right.
So a typical product like an automotive system will have 400, 500, 600 blocks in it.
Wow.
Okay. Right. It's not like I give you the automotive playback system block. It's like, no, it's built up out of these hundreds of blocks, and then you can engineer it all different ways.
So, Paul, before AudioWeaver and someone wanted to do an equivalent job, would that have been coding in C using a lot of different functions and creating whatever it may be, a biquad filter, for example?
Exactly.
Yeah.
Yep. So people would be working in C, and on the DSPs, you'd have to go down to assembly to get the full performance out of these devices. And so what we've done is, you can see there's blocks here. There's a bass tone control. That's a biquad filter. And so what we've done is we've optimized that biquad filter. on all different processor families. So on the Shark, we go down to assembly. We go to whatever level is needed for full performance. And so, we basically can set the standard for all the different operations and stuff.
And so the output you get from Audio Weaver is a library, is a .o file. What do you do with it?
Okay. So I'll get into the kind of dynamic instantiation. Okay. But what'll happen is the output of Audio Weaver tools is a net list. So it's a description of which blocks are needed and how they're connected together and configured. And so what you'll do on your product is you'll combine our library together with the net list, and the two of those realize the overall signal flow. Okay. And what's really nice about it is you're not always rebuilding the target code. Okay. So what you can do is you can be connected to the target. Okay. And as long as you're using the blocks available on the target, you can move blocks around, you can add new blocks, you can tune and everything. And so you're not always like invoking the compiler and reflashing the board. Okay. You get this really fast iteration cycle with Audio Weaver.
Oh, okay.
Okay. So one other point I'll mention is Audio Weaver is made for product developers. So a lot of emphasis on efficiency of the code, small memory footprint. We're about 15 kilobytes for the core framework. Okay. If we do a good job optimizing the blocks, then it's as efficient as, a skilled DSP engineer doing a custom implementation. Right. So we don't get complaints from customers about speed and so forth.
Okay.
So, yeah, let me talk about kind of instruction set support. So I'll basically say Cortex M4 and up, Hi-Fi 2 and up. We're working on the Hi-Fi 5 currently. We completed last year Hexagon, so we're doing a bunch of Hexagon-based products. Mm-hmm. And then next up for us is ARM Cortex M55. We're going to be starting that soon. So that'll be for next generation processor. Okay. And so we also work with a lot of different chip partners. And so what we'll do is we'll often do reference designs. And so we'll be kind of pre-integrated into these development boards and reference designs. So you can kind of get going very quickly with Audio Weaver.
Okay. And I suppose, again, from a product development point of view, your relationship with those chip partners solves a tremendous amount of problems for audio brands. We always say this, but audio is not massive volume business except for a few companies. So a lot of times guys like Intel and stuff, they don't really give any attention to the tier 2 brands and such. So this should be a big benefit to get things done on those platforms.
Right. And then a lot of the companies too have enormous engineering teams. I worked at Bose. There's like hundreds of engineers. Harman, hundreds of engineers. Amazon, Google. And not everybody can afford to have such gigantic teams to get things done. And so they need a kind of more efficient way.
Yeah, the bulk of the audio brands out there don't have those teams at all. Mm-hmm. And also the factories over here in Asia trying to execute on this, they might not have the resources to execute either. So at the tier 2 level, you're really handicapped. So it sounds like a tool like this could be really beneficial, especially for the small to medium-sized businesses.
Right. That's right. Yep. And it's a lot easier to work graphically than to be writing code.
Right.
Okay. And lots of kind of advantages to working graphically. I'll also mention we have different IP that's available. So there's a bunch of DSP Concepts IP. So a bunch of microphone processing, so you can deploy far field products. So multi-mic array, beamforming, echo cancelers. We can do multi-channel echo cancelers. We've done sound bars with Dolby Atmos in the market and voice control and so forth.
Mm-hmm.
Good noise reduction technology. We have an adaptive interference canceller. So suppose you're making a voice-controlled air conditioner, and you want the air conditioner to understand you even when the TV's on.
Right.
So we can deal with that use case. And then on the right side, we also work with third parties. So we have their IP kind of available in AudioWeaver.
Mm-hmm.
And a lot of this right now is driven by automotive. A lot of the technologies there. But our goal is to make it as really easy to deploy technologies, and then we want to have the best of the best available in AudioWeaver.
Okay.
So, yeah, let me also kind of just talk about sort of, I call it benefits beyond IP. A lot of times it's easy to fixate on IP. And if you're building a product, there's a whole bunch of things to take into account. Here are the 6 different areas. Yep, IP performance is one of them. Okay, but you care about design flexibility. Can I meet my industrial design needs? Okay, there's execution risk. Am I going to get the product done on time, or is something going to hold me up? People care about development costs, per product cost, and also, is it supported in the supply chain? So when we've kind of surveyed our customers and we said, okay, how would you rate these things in terms of what's really important to you? Okay. What we found is the number one concern that customers have is execution risk. Okay. What happens if something goes wrong during development?
Mm-hmm.
What if I miss the Christmas sales season? What if I'm delayed a quarter? Even if you're a month or two late, that really hits the bottom line.
Mm-hmm.
Okay. So a lot of people concerned about that. Next thing is IP performance, but it's not like I insist on having the best performance. I just don't want to have bad performance, if you know what I mean.
Mm-hmm.
We can all relate to like bad video conferencing experiences. Okay. What's been your best video conferencing? That's a little harder to think about.
I think this one, Paul, to be fair.
And then when you kind of look deeper, they're not that concerned about development cost issues. It's really this execution risk, IP performance. And that's really where AudioWeaver can shine with the execution risk, helping with that.
Yeah, a lot of maybe junior people that haven't gone through the product development cycle don't realize, like with traditional retail, the penalties you get when you don't deliver your product on time. Mm-hmm. and also if you have to air freight a product, again, for small to medium, that could almost put some companies out of business if they had to air freight soundbars for a Christmas rush. It would wipe them out, literally. So
I've seen those things.
Yeah.
Yep. So let me also kind of tell you sort of some of the new things that are coming, kind of what we're doing. And so what we're going to start doing with select customers is, I call it open audio IP. Mm-hmm. So traditionally, if you're supplying algorithms, that's your secret sauce. Okay. And you want nobody to see what's going on inside the box. Mm-hmm. So the approach we take with AudioWeaver is we think, look, the magic is inside the framework. Okay. We have good IP, but what we want to do is we want to encourage customers to roll up their sleeves. Okay. And start building upon the IP and modifying the IP. Okay. So what we're going to do is, for kind of skilled OEMs and design partners, so there might be some ODMs or design houses, we're basically going to open up the block diagrams and teach them how the processing works and enable them to basically take over, build upon it, and go further with it. So I think this is going to kind of revolutionize the whole audio industry.
Mm-hmm. So yeah, their secret sauce is protected, but still within the framework of AudioWeaver.
Yep.
Very cool.
And so, yeah, so this is going to be kind of rolled out. We're going to be also doing kind of more TWS. So we're going to be moving into TWS.
Mm-hmm.
And so this is, one of the things that we saw that, okay, we've got to bring to really make a dent and to improve the, TWS whole development experience.
Right. Yeah. Yeah, I saw the wind noise reduction. That's a popular thing in my world right now, is some people trying to figure out how to do the wind noise reduction on the mics.
Right. Yep. And you can see we got a wind depopper here. We've got algorithms here. Wind noise over here. So that's all built out of the underlying primitives and stuff. Okay. Kind of at a high level, we have two kind of voice technologies. One we call Talk To. So that's for human to machine communication.
Okay.
So we've done a whole bunch of Alexa type products, and just about every ASR we've hooked up to. And the other one is for human to human calling. So we call that Talk Together. And so behind both of these are AudioWeaver block diagrams. And then you can do kind of all the algorithm design. And what's also kind of unique about us is you can also do output processing. And normally the world is split into two different halves. Okay, people who do loudspeaker processing and people who do microphone processing. Mm-hmm. Okay, and often in a company, that's done by two different teams. Okay. With AudioWeaver, you can do both. Mm-hmm. And then we also encourage for voice products that it's important that you kind of jointly design the microphone processing and the speaker processing. Okay.
Yeah.
Let me give you kind of, yeah.
I was just gonna say, I saw your demo for the Pure Audio soundbar that Karl-Heinz Fink did the acoustic design. So I know who he is. I don't know if he'd remember me, but anyways, just the ability to get that barge in with a big noise floor going on. I know that a few years ago, like some brands wouldn't even entertain soundbars with that kind of barge in technology. So that's quite impressive to do it.
Yeah, and he did a fabulous job tuning that soundbar, that Pure that soundbar.
Okay.
So, yeah. So what happens in a lot of the voice products is, you want the echo canceller to work well. And what do echo cancelers hate? They hate nonlinearities. Mm-hmm. And so part of the fight is like, okay, I want to try to keep my system linear. And there may be trade-offs to be made. Okay, when it gets really loud, do you want big harmonic bass, which is like distorting, or do you want better voice performance? And so there's kind of a trade-off to be made there. So sometimes you might have to be a little more aggressive on the loudspeaker processing.
Okay.
To kind of prevent the nonlinearities.
Okay.
So we can do kind of all of the different IP and so forth. Another thing we're doing is we're working on audio prototyping kits. And so what we want to do is allow you to use AudioWeaver kind of throughout the development process. And so first one we have is, this is shipping now, is essentially a synchronized microphone array. So it'll basically allow you to do multi-channel I/O together with, one or more synchronized microphone arrays. So if your company and you're prototyping a far field speaker or soundbar, a TV, maybe an automotive system, you can do that with this setup. Okay. Before, it's always tricky to get kind of all the I/O synchronized. You can get microphone arrays, but then they often don't have the analog I/O you need or not enough of it. So we found that this solved a real common problem for our customers. And so the way this is designed is we'll leverage an off-the-shelf USB sound card, and then the microphone array plugs in over ADAT optical interface. And so you can get whatever sound card you want. I have a Behringer. Some customers use RME. There's some that have multiple ADAT interfaces. And now you can start prototyping very easily. This is one of the microphone arrays. This is what the board looks like. There's a digital mic input. There's an analog mic input. So you can use we have some form factor mic arrays. You can build your own. We also have like a fan out microphone array. So if you need to stick it on arbitrary geometries, you can do that fairly easily.
Right. Yeah, that's interesting.
Mm-hmm.
You could just start to imagine all the different products that they would be just doing, like a mechanical interface, and this is where we want our mics to be, and how's it going to work in the end?
Yeah. I'll show you kind of a use case we did recently. So we've been asked to do, hey, I want to do voice control in the kitchen in a range hood. Okay, how's that going to work with your algorithms? So what we basically do is we go make recordings. Okay, we'll just pepper the unit with all different microphones. This one even has a microphone inside near the fan to get a noise reference. And then we can essentially make recordings and then post-process and then check the performance.
Right.
So we can go, make large scale recordings and then post-process, check the performance. How does a trigger word work? How does an ASR work?
Okay.
And then you can imagine what we're doing on the right-hand side. Hey, I want to do voice control for my washing machine. Is that going to work? Can it handle the appliance noise and so forth?
Yeah.
So
yeah, that's massive challenges, but tons of applications for this.
Yeah. And this makes it real easy for people to get started, make recordings. And then the hardware is also compatible with AudioWeaver, so you can run natively on the PC and even do real-time processing on the PC. Okay. So kind of just reducing barriers. And then this one also works for automotive. So we're doing a bunch of work with car makers. And so some people are now looking at putting multiple microphone arrays inside the car. Okay. Everyone's really concerned about voice quality. My car, it's fairly new. It still has one microphone for the entire voice pickup. And I'm like, come on, we can do a better job than that.
Right.
Okay. We're also doing like POCs with some OEMs. And what they're interested in is voice recognition outside the vehicle. So maybe I can walk up to the car and say, open the trunk, that type of stuff. And so we're basically peppering the car with microphones, doing recordings, and then developing the algorithms.
And would any of these microphones be dual purpose, just like an idea question here, for like collision prevention or incident prevention as well? Like, so the system's able to recognize, is that a voice or is that something that's not really possible?
Some stuff they're looking at is, especially for autonomous vehicles, they want to be able to do, detect, is there an ambulance or emergency vehicle approaching?
Yeah.
So a bunch of people are putting stuff outside so that they can detect things. Even things like, can you listen and tell if the road is wet? Once you start thinking about it, there's actually a lot you can do.
Right.
Can you adjust the vehicle?
And there's a lot of things like people like Knowles and stuff with their microphones work on in terms of vibration detection and stuff that's kind of out of the audible range, but shows like, is your alignment off and all kinds of other functionalities as well.
Right.
So yeah. I imagine that AudioWeaver could actually be a platform for interpreting all that information as well. Yeah.
Yeah, because we're getting more and more interest from autonomous vehicles.
Mm-hmm.
And what you can imagine is the main way you can tell something's wrong in the vehicle is by the sound. That's probably the number one way you can tell.
Right.
And so suppose you're in a autonomous taxi fleet. Are you going to let them know when something's broken? Okay.
Yeah.
Or you're just going to like leave it for the next person?
Right.
Okay. And so the idea with audio is to say, hey, let's use the microphones that are in the vehicle to detect and register these things.
Okay. Very cool.
Yeah. We even had requests from companies where they said, hey, my vehicle's got, almost full autonomy. And their vision is the vehicle drives itself off the assembly line, drives itself around the test track, and then the microphones are listening for any problems. So similar kind of stuff.
Right.
So yeah, it's funny. We're engineering automotive systems now that have more microphones than speakers. It's pretty cool. Okay.
Cool.
What we're also doing, so this hardware is available now. This prototyping kit. The one that's kind of in development now is we're working on a prototyping kit for TWS. And so this is how we envision it, is we're going to build some custom hardware, and we're going to be using a NXP RT600 processor. Mm-hmm. So this is a high-end Hi-Fi 4 DSP, lots of memory. This chip is too big to go into an earbud, but it makes a really nice prototyping environment.
Okay. And
what you can do is there's going to be, multiple microphone interfaces, speaker amplifiers, even sensors. And so you can do a form factor earbud, hook it up to this, and then you could plug the board into the PC. And as a first step, you can use it to make recordings. Okay. Or you can run the AudioWeaver tools on the PC. That's kind of step one, native PC. Second step is you got a really powerful DSP there. Why don't you take your block diagram, have it run on the Hi-Fi 4, and then you can run untethered from the PC. So you can walk around, you can test out different playback algorithms, different voice algorithms, and so forth. It'll be battery powered. You'll also be able to do data logging when you're out in the field, log to flash. Third step, we're also working with some of the leading Bluetooth chip vendors. Mm-hmm. Okay. And make it easy to go from a rapid prototyping hardware to their EVKs. And so the idea is it'll be this seamless flow going from the PC down to the partner's EVK, and then finally into the final product. And then we want to be able to do full AudioWeaver functionality in the final product and communicate with the earbuds through Bluetooth.
Okay. And when would people expect to start using this platform?
Yeah, this should be ready kind of Q3 this year.
Okay.
So we're about to kick off the hardware development. And we also already have support for the NXP RT600. So we already have all the USB audio drivers and real-time audio.
All right, very cool. I know that I saw just the other day people we interviewed previously, USound, that do the MEMS speakers. They're developing an acoustic platform to plug in to TWS.
Cool. Yeah, and TWS is kind of different than a lot of the kind of other audio markets. Mm-hmm. So it seems like the chips are much more important, and then design houses too. So there's strong reliance on design houses in Asia for getting this done.
Right.
And so what we want to do is this is going to be targeted at kind of OEMs who can do work themselves, who are interested in doing stuff themselves. Mm-hmm. And we also want to target this at design houses because there's a lot of skilled design houses in Asia.
Yep.
And then this is where the open IP comes in. It's like, hey, here's the TWS reference design. Okay, it's going to have all the processing features you need. Okay, beam forming, echo cancellation, bone conduction, a lot of advanced features. And then they can take that and then they can tweak it and adjust it for their requirements.
Okay. Yeah, that's exciting stuff.
Mm-hmm. So it's kind of in development now, coming later this year.
All right, key 3.
Okay. So I have more details on AudioWeaver I can talk about, or are there particular areas you'd like to dive in more deeply?
Simon?
A couple of questions. Who uses this software need, or background do they need?
Mm-hmm. Yeah. So it's basically, if somebody's familiar with these other graphical tools like Sigma Studio, okay, then it's a pretty easy on-ramp for them to go from something like Sigma Studio to this. You do have to have an audio understanding. So there's compressors, there's limiters, and so forth. So you got to have a audio understanding to do that. And I like to tell people it's kind of like Excel. Like my mom can use Excel. Okay, she uses like 0.1% of the features. Okay. Mm-hmm. I've been using Excel for years. I use like 5% of the features. When I see our VP of Finance using Excel, he uses like 80% of the features. And it's the same thing with AudioWeaver, where you can have a acoustics engineer or a hardware engineer use it, and then he can use it for system level debugging. So pretty easy with AudioWeaver. Hey, let me measure my microphone noise floor. Let me check the AOP. Am I clipping? Okay. Are my microphones matched in sensitivity? Or the one that always goes wrong are my microphones properly ported and sealed? And so with the AudioWeaver tool, even if you're not like a DSP expert, mm-hmm. okay, if you're an embedded software engineer, if you're an acoustics engineer, you can actually get a lot of stuff done with AudioWeaver. And okay. What we have a step-by-step check. We call it real-time audio system check, RTASK, that walks you through measuring all the key things in the system. And often if you're building a product, some of the hardest products are like speakerphones. The reason speakerphones are hard to work or hard to get working is because of so many things can go wrong in the design. Mm-hmm. So with RTASK, we essentially give the customer a step-by-step checklist. Check this, check this, check this. And once the hardware and the system level issues are worked out, our speakerphone design just drops in and it works great. Okay. So that's the idea. What we also find is engineers typically like to problem solve themselves, like to find issues and fix issues. It's a lot more time consuming when it's like, okay, DSP Concepts, we'll run the test and then we report back, hey, your microphones aren't properly sealed. Then they make changes, send us another one, and then we measure it again. What the customers prefer is, hey, can I run this test myself? Can you show me how this works? And then they're real happy to use AudioWeaver to do this kind of testing. Okay. And so, so we've kind of broken it down into step-by-step processes. Even like measuring loudspeaker distortion, I told you that's like the bane of AECs. Right. And so we have simple ways for customers to measure that and understand what's going on.
Right. Okay.
Cool.
All right. Let's keep going.
Mm-hmm. Yep. One other thing is, how does someone go about integrating the output they get from AudioWeaver with their other existing code?
Yeah. Let me go show you a slide here. Okay. So what there is there's basically a runtime library. And you can think of it as a C or C++ library. And so there's 3 APIs. There's one API for real-time audio. So they basically pass in blocks of audio data. There's the next API for tuning data. This is a communication link back to the PC. So it could be a UART or Ethernet. And then there's also a control API So, you want to be able to change the volume and the tone controls on the final product.
Right.
So we have well documented APIs. We have example code. And with a lot of the chip partners, we also have the example integrations to say, hey, this is how it works on a Shark processor or on a STM32 M7 processor. So you can basically take that. We even have things like USB audio, show how to do that, microphone interfaces. And then customers usually take that as a starting point and then build upon it.
Are they often setting up so that one chip, you mentioned like a Shark processor, but the ARM ones, that's just doing the audio application, and then there's another chip and that's actually running the user interface software?
It'll depend. A lot of times, a Shark is usually a dedicated audio processor.
Sure.
But a lot of times the ARM processor is doing everything.
Mm-hmm.
And some of the integration challenges there are, hey, audio is a real-time system. And so you have to make sure you're not dropping blocks or you're not overloading the system. And so we have tools to basically verify the integrity of the audio chain and you're not dropping blocks and so forth.
Right.
Yeah. And there's a big trend in the industry now is things are moving to the ARM processors because of connectivity. Mm-hmm. We've been working with ARM for a long time. So back when they had the M4, they approached us about doing a DSP, accelerating DSP operations. And so we actually wrote the Simsys DSP library for ARM. So that's the core library of biquads, FIR filters, FFTs, statistics functions. And so by doing that, we kind of saw the capabilities of the ARM processors. And we're like, this processor is fast enough. It's not going to take on the Shark. But hey, you've got a multimedia speaker. You need USB connectivity. Maybe you're doing a speaker phone. It's good enough. You can get a lot of processing done.
What is the difference between a DSP and something like an ARM, which you'd call a more general computer, would you?
Yeah. So, first of all, they have different cores. So in terms of, you have like the Shark instruction set that's been optimized for DSP. And it has a high level of parallelism. Okay. It's really designed to do multiply accumulates, update circular pointers, and so forth. Okay. So typically on the Shark, you get lower cycle counts than on the ARM processor.
Mm.
But what happens is the processor core is just one part of the overall system. Okay. You still need connectivity. Is there an Ethernet interface? Is there USB connectivity? Okay. Flash memory support and so forth. And that's when you look at it, a lot of the traditional DSPs don't have all the connectivity that you need. And so you'll either need an ARM processor and a dedicated DSP, okay? Or if your ARM processor is fast enough, just take that and then use our software. And you kind of get a soft DSP.
Yeah, I see. So it's a question of whether or not the general computer is just fast enough to
just fast enough,
maintain real time,
Yeah. And we also have kind of full benchmarks so we can compare all the processors and how efficiently they run and so forth.
So if you're developing something in Audio Weaver, how do you know if you are going to overrun the availability of processing power of the device you're working on?
Yep. So what you do is you would hook up one of our development boards and then you can run in real time. Mm-hmm. And it'll do like cycle accurate profiling for you. And so you'll be able to see on a block by block basis exactly how much processing power it takes.
Right.
Okay. And then we've also published papers showing like comparison of efficiency between different processors and all that.
Interesting.
Okay.
Yeah. So a lot of times what will happen is the customers, they'll start out on the PC, they'll create their block diagram. So maybe they'll build a 20-channel automotive system. They'll put all the processing they want, do it on the PC. And then what they'll do is they'll send it to us and they'll say, hey, Paul, can you profile it on the following processors?
Right.
Okay. What is it going to be on a Hexagon DSP, on a Hi-Fi 4 DSP, a Shark DSP, a TI DSP? And then we can give them actual real life measured numbers on those different cores.
Right. Okay. I suppose that might be an interesting situation now with chip supply. It's like, which chip can we? Well, that one's not available. Sorry. So let's trim the DSP a little bit so we can get an available chip, perhaps. Yeah, fascinating.
So software integrations, straightforward from an API point of view. There's not that many APIs.
Okay. So
that's basically it for me.
Yeah. Anything more to add, Paul?
That's the bulk of it.
That's the bulk of it. Is that enough for everybody? I guess we can get their comments below. Let's give people a shot. So the website is dspconcepts.com. They can go there and find all about Audio Weaver, and we will put the Twitter and the website URL in the description below. And we encourage everybody to hit us with your comments and questions. Tell us what you think. And of course, all that good YouTube stuff, like, subscribe, and share. Paul Beckmann, thank you very much for joining us today. Really appreciate your time.
Thank you, David. Thank you, Simon.
Thanks,
Paul.
Paul.
It seems like a great platform. So we'll say goodbye to everybody for this week, and keep watching if there's plenty more content coming up on your YouTube. Okay, bye, everybody.
All right.